So in the last video on acid-base neutralization, we spoke about the fact that if you react an acid with a base, you actually get a salt. And sometimes you also get water if your base has some hydroxide ions, right? Cool. So now in this lesson, we're going to talk about when we actually when we have a reaction between this salt that was formed during that reaction and it reacts with water, right? But before we go there, let us just do a quick revision on the pH scale. So remember, the pH scale is from 0 to 14 with 7 in the center, and we know that substances from that have a pH that is greater than 7 are bases, right? And then substances that have a pH that is lower than 7 are acids, right? So it's kind of important for you to know that information. So we can have a number of reactions. So we can, let me just draw this quickly. So we can have a number, so we can have an acid reacting with a base to form a salt, and we can try to approximate the pH of that salt. And how do we do that? So we can either say, okay, if we have a strong base and we react it with a weak acid, a strong acid, we react it with a weak base, our salt is actually going to be slightly acidic because we used a very strong acid, right? It means that the pH will actually be less than 7, right? So, however, when we have a strong acid and we react it with another strong base, we'll actually get a neutral salt. And that neutral salt, its pH will actually be 7, right? Cool. And then if we have, so remember, neutral substances have a pH of 7. I don't know if I mentioned that when I was drawing that pH scale, right? Let me return it. So substances that have a pH of 7 are neutral. And then if you're reacting a weak acid with a strong base or with another weak acid, we will also have a neutral salt, and its pH is approximately going to be 7, right? And then if we have a weak acid and then we react it with a very strong base, it will form a slightly basic salt, meaning the pH is actually going to be greater than 7. So that's how you can approximate the pH of your salt that you form during that acid base reaction by simply reacting it with water and measuring the pH of your solution, right? So I'm trying to see if I have left something. So we can just look at a few examples. So let us take an example. So we're saying that we have a salt here, sodium chloride. We hydro and it goes through hydrolysis. So we add water, and we're trying to see whether our solution going to be basic or acidic. The pH, you're gonna try to approximate the pH. So we can take an example where we say, okay, we have HCl, which is a strong acid, plus sodium hydroxide, which is also a very strong base. Which we have done in the previous lesson. So this will actually form a salt, sodium chloride, plus a little bit of water. So we're trying to determine, will our salt be basic, acidic, or neutral, right? So because we have a strong acid and a strong base, it means our salt will actually be neutral. This means that it will have a pH of about 7, right? But if, for instance, we had a reaction between, so we can also react, what is this? Acetic acid, which is a very weak acid. So don't be confused by this OH and think acetic acid is a base, no. And we reacted with a strong base. Let us take sodium hydroxide again. And this will form a salt. So the salt that will be formed will be CH. So this will donate the, what is it? The proton. And then it will form the salt plus water. So we're trying to determine, is our salt here basic, acidic, or neutral? So because we reacted a weak acid with a strong base, it means our salt is likely going to be basic, meaning the pH will actually be greater than 7, right? I hope that is clear.